All right. Okay, everybody. Welcome to our first Unit 2 video. And this video is on partial derivatives. All right. This is an extract from a page in your book. It says in Unit 1, when finding the derivative as the instantaneous rate of change of one variable with respect to another, only one independent variable and one dependent variables were present. By definition, f prime x, which is the first derivative of the function f of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. We can extend this result to a function of two or more variables. We find the derivative of the function with respect to one variable while holding the other variable constant. This is called partial derivative. So the very first thing I'd want you to note here is that partial derivative involves finding the derivative of a function with respect to one variable while holding the other variable constant. Alright? So it's in essence, if you have some function of f and y and you're differentiating this function with respect to x, essentially what this statement is saying is that you're going to treat y as a constant. You're going to treat y within this function as a constant. And a constant here would be like just a number. For example, if you differentiate, let's say, 3x with respect to x, you're going to get 3. The first derivative of 3x with respect to x is 3. Now, if you have a function, let's say yx or xy, and you are differentiating this function partially with respect to x, when you differentiate xy partially with respect to x, you're going to treat the y in that function as a constant, just like how 3 is a constant. All right. So as we progress, I hope it will become clearer. Notation for partial derivatives. It says if z is a function is some function f of x and y, then the first partial derivative with respect to x is represented by delta z, delta x. Now, delta z, delta x is the first partial derivative of z with respect to x. This is the same as saying delta f, delta x, or delta f by delta x, and which is the same as saying f subscript x comma y, f subscript of x and y. All right. So and the first partial derivative with respect to y is represented by delta z delta y, which is the same as delta f delta y, which is the same as saying f subscript of x and y. To find delta f delta x, which is the first derivative of f with respect to x, differentiate the function with respect to x while keeping y constant, and to find delta f by delta y, differentiate the function with respect to y while keeping x constant. All right. When I say keeping x constant, you treat it as if it is a constant. Here's an example. Find the partial derivative delta f by delta x and delta f by delta y of the function. So we have the function f of x and y is equal to x cubed plus 4x squared y cubed minus y to the fourth. All right, so let's differentiate. Um, so f x of x and y, which is the same as saying delta f by delta x, would be equal to, so um, so what you're going to do is that you're going to differentiate the function while with respect to x while treating y as a constant. So if you differentiate x cubed, you're going to get 3x squared. Now let's differentiate 4x squared y cubed, treating y as a constant. If you differentiate 4x squared, you're going to get 8x, and treat y as a constant, you're going to write it back. So that's y cubed. All right. And if you're treating y as a constant, if you differentiate a constant with respect to x, you're going to get 0. So if you differentiate minus y to the fourth, treating y as a constant with respect to x, it disappears. All right. So that would be the first partial derivative of f with respect to x. Now, f y subscript y of x and y, which is the same as saying delta f by delta y. So we're differentiating the function y with respect to the function f with respect to y while treating x as a constant. So if x is a constant, it means that x cubed is going to go because it has no y in it. And 4x squared to the third is going to become 12x squared, and that is y squared. The power decreases by 1. All right, minus, and then we have 4y, and the power decreases by 1 to the third power. All right. All right. Example 52. It says find delta z by delta x and b delta z delta y if z is equal to. All right. So if you look carefully, you can see that this function is a product of two functions in x and y. So let's find a. A is delta z by delta x. That's differentiate the first derivative, the first partial derivative of z with respect to x. So therefore, we're treating y as a constant. Using the product rule, we will leave the first. So that is x squared plus y. Leave the first. Differentiate the second. Differentiate cos to get minus sign. So it's times minus sine 2x squared y. And for chain rule, we multiply by the differential of the inside function. The inside function is 2x squared y, and we're differentiating that partially with respect to x, treating y as a constant. So we'll end up with 4x y. So we leave the first, differentiate the second, plus differentiate the first, we get 2x, leave the second. Y is a constant, so therefore if you differentiate a constant with respect to x, it goes. So we have 2x, differentiate the first, leave the second, cosine 2x squared y. Alright, so The answer is, let us simplifying it or writing it prettier. We have minus 4xy, open bracket, x squared plus y sine 2x squared y plus 2x cosine 2x squared y. All right, let's go for B. B is the first partial derivative of z with respect to y. So we're going to differentiate the function z with respect to y, therefore partially with respect to y. Therefore, we're going to treat x as a constant. Remember, if you differentiate a constant with respect to y, the constant disappears. So literally treating, so it's a product differentiation. So we're going to what? Leave the first. We're going to have x squared plus y. Differentiate the second. So that's time minus sine 2x squared y. Now we're going to multiply by the differentiation of the inside function. So if we differentiate 2x squared y partially with respect to y, you're going to treat the 2x squared as a constant. So it's going to be multiplied by 2x squared. All right, it's sort of like differentiating 3y with respect to y. If you differentiate 3y with respect to y, you're left with the 3. So if you differentiate 2x squared y partially with respect to y, you treat the 2x squared as a constant, just like 3, and you just leave it. So it's what? Leave the first, differentiate the second, plus differentiate the first. If you differentiate x squared plus y partially with respect to y, you're just going to get 1 times the second. Leave the second, which is cosine, and we have 2x squared y. So write it in prettier. We end up with minus 2x squared x squared plus y sine 2x squared y plus cosine 2x squared y. All right. So that is your introduction to partial derivatives.